So good morning, everybody. Obviously, the topic today is going to be agents of one form or another. And I have to admit that this is probably the single most exciting class in the whole sequence. And the reason is that it's a very complicated area right now. People have said 2025 is the year of agents. Question before we begin. Pardon? Oh, thank you. How's that? You got it now? All right, thank you. Thank you for putting that up. So as I was saying, this is multiple AI pundits have been saying 2025 is the year of the agent, and implying it's the beginning of the decade of the agent. And so we're going to talk about what agents are today, and why the year of the agent actually probably started in 1995, but whatever. So like with many things, this takes a while for it to spin up and become a part of what people think of as everyday technology. But it's a huge amount of stuff that's out there right now. There's an entire snowfall. It is a blizzard. And so I've been trying to deal with the berg of intelligent agents. So before it all explodes, I thought I'd try to give you my version of what's going on. But to start, as usual, I want to start with AI news you can use. And we're almost done with grading the second assignment. We're starting on number 3. So in particular, I want to point out this thing. So this is what I did for one of the, just solve the problem. And I tried this day before yesterday. So here's the invitation. This is a prompt you might have done, right? And if you're like most people, you got a complicated kind of weird text sort of thing. And when I did it, I got a really beautiful text. So this is new. This is new as of like a week ago. So you are the last class to ever do this assignment. There's no point in doing it anymore. The point of this particular assignment was to point out the problems, the limitations of generative AI imagery. And does a good job, leaves a place in the center. The text is all correct. And even more, there's been this huge sort of change in the force, because not only can you give text-directed prompts which include text and descriptions of the imagery to include, but you can take something like this. This is an image, and I handed it to ChatGPT and says, hey, build me an image, an invitation using this as a guide. Okay, meaning stylistically, fontistically, layout-wise, all that stuff. And what happens is you end up creating something like this, right? So this is new, and it's sort of an interesting capability. You can basically give a guideline that doesn't rip it off exactly, but slightly moves it out of copyright, which is sort of interesting. So you can see the Let's Celebrate's the same, but it included all of the other information I gave it, where it was going to be, time, all that stuff, which is new. So what this means is you can do stuff like this now. I found this on X the other day, using this cosmetic website image in the upper left there. Using that as a guide, create a advertising splash page for a bakery. So it substituted a croissant for some kind of makeup thing. It's pretty remarkable. This is impressive stuff. It's not 100% right, but it's very, very close. And you can see what's going on here. So I just wanted to say congratulations for being the last class to do assignment 2. So what I want to talk about today is, I actually have 2 topics for today. One of which is we're going to start off with agents, talk about what agents are, what they can do, and all that, issues with agents. And then we'll switch to talk about large language models. And this is all by way of setting up for Peter Norvig, who will talk tomorrow about using language models to do coding, the upsides and downsides of that. So agents are basically things that do stuff for you. So it's pieces of code that actually go out and act in the world in some way. Now, you've always been able to do this. You could write a piece of code, a glue code, through using some API to say Excel or to whatever, and make things work remotely, right? People have done that forever. The new thing about this is that you can give it an agent, an AI agent, a goal, and it will plan the sequence of steps to take, and then do it on its own. So that's autonomous behavior. Think about that. You're launching an agent into the world and saying, go ahead and do stuff. I know you'll do the right thing. We'll come back to this, okay? So it's not a new concept. A good friend of mine wrote a paper in 2008 about intelligent agents. So the concept has been around forever. What's new is that it's in ChatGPT and is easily accessible. You can do lots of interesting things with it. That's the new thing, is basically the user experience. So an agent is basically some AI system that takes in information and then takes actions to achieve a goal. So I say, do X, and we'll go ahead and do it. Most common use case, and the reason people are so excited about it is that you can replace all those customer service representatives with an agent. So the idea is it will lead to huge cost savings, and potentially improve the quality of the information being given to the person. We'll see, right? The other thing people are very excited about is the opportunity to optimize and make cheaper and faster workflows. So if you're in an office and you've got to take in all these receipts, then do some processing with it, and blah, 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 right, we can put an agent on that. So if I was a paralegal, for example, I'd be very worried about my job. That's the kind of thing that agent technology can easily replace. So in particular, you could do something like this. Just say to your agent, order me a new ice cream scoop on Amazon, go off and do it. You can imagine that code, right? Buy me a new domain name and configure its settings. I'm asking you to think about what the AI implications are for the person. What does configure its settings mean? I have a domain that I still haven't figured out the setting configuration for it, right? So there's a lot of hidden stuff there. Book a Valentine's Day date for my wife and I. Schedule a haircut. These are all fairly straightforward, but I'm going to show you an example of number 3 in a bit. Get an appointment with my manager's manager. So the system has to process who that is and reach into your organization's directory, online directory, and pull it out and do all that stuff. Or do something as sophisticated as create a whole new marketing campaign for my new AI-powered shoes. They're awesome, right? So when you do that, you can imagine it inventing a color scheme, a font, face, image design, all that stuff. You can imagine it writing social media posts for you. Go wild. What else could an agent do for you? Oh, it could schedule them for optimum effect in the market, right? And then post them, right? So right now we've got people who do all this stuff. So I might have a group of designers, I might have a group of marketing people, and I would say, hey, let's build a new campaign. They would do all these things. Could I build one agent that would do this? Perhaps. So I want to show you a little demo because normally I would give you examples of research that's in the literature about people using these. Nobody's done it yet. So the CHI conference, which is coming up in a couple of weeks, will be a few papers on this topic. And there's a bunch of people doing work on it right now. But it's better just to show you what's actually out there right now. So let me show you this. This is the operator. That's the name, operator. OpenAI is terrible about naming. They just don't know what to do. But they called their agent technology operator. Okay, so let's watch a little bit of that.
Okay, so in this case, again, operator quickly.
Pause that real quick. Context here, they're in the middle of a demo, and they have told it, I'm searching for items on this, I want to make some dinner with this list of food. It has parsed out the text, so it knows it's looking for eggs, spinach, mushroom, chicken thighs, and chili crunch. And it's going to look at Gus's market that's online, okay?
Okay, so in this case, again, operator quickly actually recognized using GPT-4o's vision capabilities to understand that the image said egg, spinach, mushroom, chicken thighs.
Yeah.
It will do a search, initiate a browser, and it's going to go ahead and
That's an interesting
start doing-
step. It just instantiated a browser. It's not calling an API for the browser. It actually opened a browser and it's moving the mouse around and clicking on the instance of the browser. Right? Darn. I always forget.
Applications and go from there. I'm curious what's happening here, though, Ray. Do you want to
Yeah.
tell us a little bit about it?
So now that you've seen a bit of Operator, let me talk a little about the research behind it. So Operator is based on a new model we've trained at OpenAI, which we're calling the Computer Using Agent, or KUA for short. So KUA is a model built off of GPT-4o, but it's also trained to use and control a computer in the same way that humans can by just looking at the screen and using a mouse and keyboard to control it. Before, if you wanted to build something like Operator without KUA, you'd need to use some specialized APIs. For example, if you wanted your model to buy stuff from Instacart, you'd need to figure out if Instacart had an API. You'd need to figure out if that API had all the functions that it needed.
I'm going to stop that for a second because they're covering up for how slow it is. They're just talking on top of it. But I will jump ahead a little bit here and show you that it actually ends up in Instacart.
Think about like Operator fires up this remote browser to do it. We almost think of it as a surface area where Operator can work and then I can work. For example, in this case, I took over control from Operator, which is also key to sort of how we think about user.
So that's an important thing. Part of the user interaction here is you watch this whole thing playing out on your display, and then when something starts to go a little wrong, you can interrupt. You can basically Control-C into it, right? Stop what you're doing. It doesn't abort the process. It stops the process. And then you can say, let's repair the plan, or let's change the action, or something like that. Now, this is very slow. What are you going to do when it's really, really fast? Right? So that's one thing. I want to show you also part of this video. So this is from Google. It's kind of the same idea.
I'm going to start by entering a prompt. Here, I have a list of outdoor companies listed in Google Sheets, and I want to find their contact information. So I'll ask the agent to take this list of companies, then find their websites and look up a contact email I can use to reach them. This is a simplified example of a tedious multi-step task that someone could encounter at work. Now, the agent has read the Google Sheet and knows the company names. It then starts by searching Google for benchmark climbing. And now it's going to click into the website. You can see how this research prototype only works in your active tab. It doesn't work in the background. Once it finds the email address, it remembers it and moves on to the next company. At any point in this process, you can stop the agent or hit pause. What's cool is that you can actually see the agent's reasoning in the user interface so that you can better understand what it is doing. And it will do the same thing for the next two companies, navigating your browser, clicking links, scrolling, and recording information as it goes.
Notice they sped up the video.
You're seeing an early stage research prototype, so we sped this up for demo purposes. We're working with trusted testers to make it faster and smoother.
Okay, you get the
and
idea.
It's so important.
So that's the equivalent thing from Google. What they have is their language model runs over here, their agent model runs over here, and this is their controlled browser over there. Yeah. So an agent is a bunch of things. It's an AI process that has reasoning capability. So it can make some inferences. We'll talk about inferences, what that means in a little bit. But it does inferencing, has the ability to identify patterns, do all the normal stuff. It can act in the world, usually by using a thing like that browser component we saw. So no fancy APIs here. It just has a connection to some browser, which then acts on the world. It then watches what's happening in the browser to see what's coming back, extracting information. So it's observing. So reasoning, acting, observing. It can plan. That's a key component of AI agents, is that they make a multi-step plan. So if I say to you, would you please write a research report on topic X? You would probably say, well, I'm going to do this, I'm going to do this, right? You have a plan, and that's what they mean here. So an AI agent creates a plan to follow. And the idea is, this is a little bit in the future, is collaboration with other agents. So where this is going, I'm not going to talk about this much today, but where this is going is that you can have a multitude of agents all working together on your task. And the ultimate goal of a lot of this stuff is that it will get better with time. It will self-refine. So the AI agent will observe what it's doing and then modify its own training. Awesome. So they've been around for a long time, and the key that people have been trying to implement in these things is basically to have human-like interactions. With the ability of large language models to provide really high-quality conversational interaction, that's gotten a lot easier. They have pretty good decision-making capability, but the previous ones, say 2 years ago, were basically reactive. And so people built agents, but that would react to a particular kind of set of circumstances. So if you're a programmer, imagine setting up a cron job. It wakes up every couple hours and checks the state of the world, runs some code, does something, and then goes back to sleep, right? Same kind of idea here. So we've now got a world where large language models have changed the notion of programming. Has everybody heard of vibe coding? Anybody? Okay, a couple of people. It's the same people keep raising their hands. Okay, so in 2016, for example, to build a data analysis agent that would answer a question like, what were sales for product X in Northeast region for Q2 of last year? To do something like that, you'd have had to do these steps. Build an agent to understand the question, so NLP processing. They would then turn that into SQL. You'd then run the SQL and then create the dialogue, more NLP, to actually give the information back to the person and have this in a chat model, right? And then another agent to create the visualization, and then one agent to orchestrate all this, okay? So that's 5 different chunks of code. So now, however, to do the same kind of thing today would take you half the amount of time. You don't need to manage the dialogue flows. You can basically give a prompt that will do that. So the world is very, very different. That's why I wanted to show you that, tell you you were the last class to do assignment 2. The world is changing very, very quickly. This is not a class to teach you how to build AI agents. I'm giving this as a list to you so you can go read these couple of blog posts if you want to go build your own. This is a class about how do we think about talking to agents, how do we understand what agents do, what's the user experience of an agent. Because now we're no longer in the realm of just designing buttons and colors and palettes and fonts. We're now designing behavior. I want this user agent's behavior to be something I can understand. Oops, in there. I'll show you that in a sec. Oh, let me show you this. Sorry, I didn't include this. Part of the reason I want to show this to you is to show you part of this demo. So this is their demo running. I'm not going to play the audio, but this is not sped up. The reason I'm telling you this is all the other ones are going to speed up as well. If the model of interaction with an agent is that you're kind of watching it work, A, nobody's going to do that for more than a couple of minutes. B, if it's going this fast, you can't actually monitor what it's doing. So what we need to think about is how do we design this agent's behavior to check in with you, the human, every so often at some relevant checkpoint. There we go. Okay, so for the UX, we need to be thinking about how do we build these things so they are trustworthy, that I have trust in them. As we've said in the past, trust is really a reputational thing. It's developed over time. I tell the agent to do something, goes off and does it. Great. The way the problem is solved actually matters because the reasoning methods have to be aligned with your expectations and your understanding. An agent that goes off and does voodoo in the side and then says, here's the magic answer, is uninspectable. You're not going to trust it. You're not going to believe it. So the way the problem is solved by the agent makes a difference. As you can imagine, you have to give these agents all of your passwords, all your IDs, all your privileges, all your credentials in order for it to log in, say, on Swissair and buy a flight. Agent, buy me a round-trip ticket to London on Swissair for next week. Okay? What would it do? It has to log in, credit card, all that stuff. So all the normal security problems are now in the hands of an agent that you may or may not understand all the time. And if you're going to build these agents out in enterprises, which you will probably see, work with in the future, we need to be able to have business rules and models that are enforceable by the system. Okay? So we need to figure out what's okay and not okay to say, for example, in your business chat. So there are a few agents out there, and one I want to point out for you today is what are called deep research systems. So Gemini's got this, Perplexity's got this, Claude has got this, OpenAI. So this is my demonstration of using a deep research model from Google. So this is a Gemini deep research model. And I gave it this goal: write an analysis for graduate students about the history of the development of Zurich as a city. Pay attention to the architectural aspects. Reasonable, right? And so I let it run, and it gave me here a plan. This is pretty nice, right? It said what I'm going to do. It rewrote what I asked it to do, and then said, first, I'm going to research earliest known settlements. Second, I'm going to investigate the Roman settlement of Turicum. Third, I'm going to add, architectural, so on, so on. And I look at that, and that's great. What's the interface here? You can actually go edit the plan, right? You want to predict how many people are going to edit the plan? Approximately 0, right? This is not a super user-friendly interface, right? So it's very clear no UX person touched this, right? It gets worse. But anyway, and then of course, so here's the plan, and then it says I'm going to analyze the results and create a report. That's not inspectable. What does analyze results mean? I don't know. Does it count the most frequent words? What? What's it doing? In any case, I let this run. I said start research, bottom right. And as I'm watching, it says I'm researching 134 websites. That sounds pretty good. And a lot of them you'll recognize are from the Zurich city website, zurich.com, right? There's Wikipedia in there. There's some place I don't recognize, something like Celtic Past. And so this all kind of makes sense. Oh, it keeps going. It's 134 websites. Who audits this? The reason I'm bringing this up is that what I've done not this one, but other examples using deep research models, I found some pretty low quality references in that site. And I had to go through and manually say, don't use that one, don't use that one, right? Zurich for kids, that kind of thing. No, don't include that in your research, that kind of stuff. And so a big problem for this is that there's no notion of quality. I mean, the Gemini is going to try to produce whatever, it's going to use whatever Google gives it. But what you will see are things like this. That's in there twice. Oh, really? So this is the report it wrote. It's about 2,000 words. It's kind of fine, but a couple issues. A, this is terrible typography. Really, you could do a better job. So the user experience of this is like, yeah, it's the big block of text. I'm not going to fact check that, right? So it does, actually, I did fact check it. And it does an okay job, although it spends 2/3 of its time on prehistoric Zurich, because there's a lot written about the very early Celtic and pre-Celtic places here. And then, of course, at the end, it gives you this nice timeline, but there are a couple problems. A few of these are out of sequence, right? So there's something that was completed in 1698, and then this was done a couple centuries before that. It's not a linear timeline. Oh, poor human, you think time should be linear, right? So there's a problem like that. Or the Rathaus date here is correct, but the cited work, there's a citation there. That's what these little numbers are. You click through. It doesn't say anything about the Rathaus. It's completely irrelevant. So there are quality problems still. If you're letting an agent do the work for you, you really care about the quality of it. I'm obsessive enough to check. Most people are not. So let's talk a little bit about the difference between these different words you might have heard. So a bot You know about that, right? Basically do very simple things. There are chatbots out there. They automate very simple tasks. So, for example, at work, we used to have a chatbot, which was a Python beginner's chatbot. You could chat to it and say, how do I, blah, blah, blah. And it would then give you back an answer for that. Nobody does that anymore now. People just ask ChatGPT. So it's pretty limited. An assistant is a little bit different than a bot, slightly higher level, responds to prompts or requests, and it's reactive again. But an agent actually autonomously and proactively takes action in the world. Right? Now, you might have heard this idea called HEI, right? We're going to talk about HEI in a couple of classes, but this is getting very, very close to HEI, where it's general intelligence and it takes action. So the definition of HEI varies from person to person. Sam Altman at OpenAI will say it could do something that's some human activity economically valuable. I think it's pretty limiting, but whatever. But people have very different definitions. But this is where they're going. And so agents like this, like the OpenAI operator agent, can take action autonomously, perform complex multi-step tasks, and it's proactive. Okay? So when we think about agents, one way to think about it is sort of architecturally. And so from the UX perspective, you have to think about, this is what I hope people are working on right at this point. So if there's a user out here, an agent has role, personality, communication style, and so on. So one way of thinking about this is that when you design the agent, you're designing a persona. I will tell you that most companies I know about have persona teams. Okay, now this sense of persona is not the UX research persona. This is the persona of the agent. So do you want it to be a British butler? Do you want it to be a slangy great dude from the West Coast of California? Or how do you want this thing to be, right? Or do you want it to be selectable? I only want to talk to upper crust British butlers, please, right? That kind of thing. Or do you want just, whatever. So people design these personas, and they want the role, the behavior of that thing to be consistent with that. So it's going to be language choice, accent choice, method of description, all that stuff. So an agent also has memory because, for example, if you're going to have your agent log into Swissair and buy your flight, it needs to know who you are, your passport number, your credentials for your security cards and all that. So it needs to have that. Ideally, you want your agent to learn through experience. So I'm going to tell you once, agent, here's my credit card number. Here's my credential. Don't ask again, please, right? Of course, what will happen inevitably is it will fail when your credit card is stolen, you have to get a new card, and then you have to tell again. That makes sense. Do you want, for example, hypothetical, do you want your intelligent agent to text you at 1 in the morning saying your credit card was just denied, what's your new number? Okay? So that has to go somewhere in the persona, like don't wake me up after midnight, dummy, kind of thing. So an agent also has access to all these different tools, right? So it has access to browsers, spreadsheets, et cetera, et cetera. So the way it's doing it now is they've got this universal solvent, which is the browser. And so anything that's accessible through the browser can, in principle, be used by the agent. And of course, underlying all of this is what you have in all large language systems, is you have some model, right, running underneath that. And there's actually two models. There's the one which is the general model of knowledge about the world. It's a classic large language model, which we'll talk about in a few minutes. Classic model, but there's also the personal model, the model of me, Dan, or the model of all the rules and regulations that adhere to me as an expat living in Zurich. You don't want to know. There's a lot of them. Okay. So when you're interacting with an agent, the way you might think about it is as a personal assistant. So, hey, agent, I want you to achieve this goal. Here's an interesting question. How do you articulate that goal? How does it know what you mean by that? Can you verify that goal, right? So you have a conversation. You have a little conversation to clarify and determine what success would mean. Also, implicitly, what failure might mean. We have some mechanism for monitoring how it's behaving, and you have some way of intervening. Do you Control-C it or click on it, or what do you do? And in general, how do you understand what your agent system is doing? So there are a lot of different approaches to this. I want to show you one little clip from a video of a group that's trying to build a system that allows people, primarily developers, this is not intended for mere mortals, but developers can use this system to look at an agent trajectory. And what they mean by that is what steps an agent goes through to achieve a goal. Okay? So let's watch a little bit of this video.
Hi, this is Catherine from LangChain. Today we'll chat about evaluating agent trajectories with agent evals. We often evaluate the final response from our agents, but sometimes an agent can arrive at the correct final response with inefficient or incorrect paths. For example, here's a situation where I asked for a meeting on Friday, and if we scroll into the final response, our scheduler agent correctly responds that it has set up a meeting on Friday. This seems
Pause. It did the right thing. It set up a meeting on Friday, right? All is well. However,
correct for the email output, but if we take a closer look at the trajectory here, it only calls the get calendar tool. It never actually called the scheduled calendar tool that it's supposed to. It simply hallucinated the result. This is an example where simply evaluating on the final step is not enough, and it's necessary to evaluate based on the trajectory that our agent has taken.
so I think that's super interesting. It hallucinated the right answer, but by looking inside the trajectory, that is a sequence of steps of what it did, you can see it skipped a whole step, and it just sort of guessed at the right time, and it got lucky. It got lucky. Agents get lucky too, right? So this is one way that you or I, as system engineers or as UX people, might look at the inner workings of a thing. And this is pretty simple to do, but you get the idea.
Which can be really helpful for complex agents with multiple steps and tool calls. And this is
Anyway,
Hi, this is Catherine
it
from
goes on.
LangChain.
Stop.
Today
stop. So I want to think about failure modes for a minute, because we just saw a failure mode, which was it hallucinated that time and set up a meeting based on a hallucination. But this is, actually, if you click on the demo, you can watch the whole demo yourself. But she did this last month, or a month and a half ago. And what she did was, right after Operator came out, she said, hey, I want to use it, and I want to set up a romantic getaway with my hubby, and I want it to be from February 5th to the 14th. You notice anything here? That's the 4th. That's not the 5th. At some point in its development cycle and in its operation cycle, it changed the date. And it didn't throw an error. It just said, fine, here you go. This is a better deal. Trust me. Right? So if you actually go and watch this video, you'll see that it gets sped up a lot. Let's assume that the engineers will handle that and things will get faster and cheaper and better. But how do you fix a problem like that? So that's what the previous video was trying to show you. Here's a debugging tool for that. Now, the real issue, of course, is that people are not going to do this. What they're going to worry about is this thing going off and setting up a flight to New York, getting a very expensive hotel in New York, billing it on my credit card, and then I find out later that I have to leave a day earlier to get there. Right? So when does notification happen? So I want you to spend a couple minutes here thinking about this. Remember the example I gave earlier about creating a new marketing campaign? for your new AI-powered shoes. You can imagine what that does. You know, I don't know, monitors your running style or something. It does all these things. What could go wrong? Let me give you 3 minutes to talk about that with your partners. Go ahead. You're going to have to stand up and move. There you go.
Optimum is like a really broad word. Yeah, I think it's just careful because it's not specifying. Just making sure that you use your optimum. Yeah. So much room for.
All right, everybody, what have you got? What have you got for me? What do you say?
Okay, so I was proposing that it might be problematic if it was not context deaf, but like deaf to what is going on around the world and much complain about like a problematic topic that might be related. Like for example, I was saying like whatever my friends gave an example exactly.
Yep.
Like for example, we thought it was quite funny, but
Right.
the day the Queen died, it was like if it was like, oh, the Queen would have loved this product.
Right,
Like,
right.
So
That's okay. So, in fact, I think, yeah, I have an example like that. I will tell you about a real example like that happened. So, as you know, Google's ads are basically an AI system that picks an appropriate ad to show on a web page. So, does that, right? So, one thing that happened, this no longer happens, to be honest, but once upon a time, there was a big plane crash in the news, right? And an ad that was run below it was, fly American Airlines, right? And it's exactly what you just said. So inappropriate recognition of the context, right? That's a good one. Anybody else? Yeah.
I would say there's not enough information. If I would have to solve this problem for myself, I have no idea what to do.
Oh, okay.
If it is with agent,
Right.
you do something, but you have no idea what.
Oh, this is interesting, because how smart is this agent, right? Does it actually know how to develop a marketing campaign? Do you trust it to do that? It does. You don't know what it knows, basically. Yeah, yeah. Okay. Anybody else? Yes.
There's like a huge monetary incentive for the companies operating these kind of AI systems to like prefer certain tools over others, for example. Booking instead of Airbnb or something.
Right, right.
There will be a huge problem with that if everyone's going to use an agent.
Yes.
Like a monopoly.
That's absolutely right. So the big issue here is, to what extent does monetary considerations end up affecting the agent's behavior or recommendations? So, for example, if your agent, your personal agent, was actually sponsored by American Airlines, you're going to fly American everywhere, even when it's painful to do so, right? You'll never fly on Swiss, that kind of thing. My little group identified an interesting question, which is, what about plagiarism? What if your agent goes off and just rips off a Nike commercial? And people go, wait, it's clever, but it's, illegal borrowing. So when I thought about this question, I had a couple things here. One of which was posting after newsworthy event where the shoes were involved in a material way. So it's the Queen died, or somebody robbed a bank and then ran out of the bank with these fast AI-powered shoes. You don't want that to happen either, right? Another one, notorious crime. The third one I want you to think about is, who monitors the posting to social media? So right now, if you're the marketing manager and you develop his marketing campaign, you're responsible for watching both the postings going out and reactions and so on, right? So there's somebody, a human agent, whose job is to be in the loop for monitoring all these kinds of things, right? But if you set up an agent to do this, who monitors the agent monitoring the campaign? Here's another failure mode. So an agent can easily set up another agent, right? So set up a shoe campaign for the AI-powered shoe, sets up an agent to set up the campaign, and it says, oh, I'm going to set up another agent. I'm going to set up another agent. You see the problem? This is a kind of failure mode. There's lots of discussions of things like this, but when they have an agent that can create another agent, grow another agent, how do you prevent it from producing 10 billion agents? Okay. So what I wanted to talk about today was, this is a quick review, then we're going to switch to large language models. So what's an agent? We talked about that. How do you guide these things? And I want to leave you with this notion of agent failure modes, because I don't think we started to even see the failure problems we're going to have. So there's the chaining infinite numbers of agents problem. The second order problem is, once you set up an agent, when does it go away? Right? If you're just buying groceries like we saw in the OpenAI demo, it goes away once the groceries are purchased. It's done, right? But suppose you set up a campaign, a marketing campaign. Do all agents come with a timeout? I hope so, right? Or if you have an agent that's chaining other agents, creating other agents, how many agents can it subcreate? When do they time out? And how do you know how many agents are working for you? Right? So I set up an agent that watches for really great deals, say at Globus or something, right? It's watching to see the opportunities that are available to me. But then we set up one for Amazon, we set up one for this company and that company, and all of a sudden we've now got 10,000 agents all monitoring for the various deals for me. When do they go away? Suppose I die. I get hit by a train. those agents are still there, consuming resources. The agent apocalypse is upon us. So that's an actual real issue. You can't just necessarily reboot the data center, right? So how do we monitor agent activity? Now, obviously, you're going to have a budget, so at some point you'll notice, oh, we just went over 100,000 francs, so maybe you'll notice then. But it might be your errors that do that. Okay, so let me switch topics here. You're not supposed to see the middle of this. I'm going to give you just like a quick intro to this, then we'll take our break and we'll come back and finish this off. Okay, so on your question, oh, this is not this is protected too?
Yeah. Yes.
Dang it. There you go. I try to catch those before I come to class, but I don't always get it. So you've heard a lot about large language models. You probably already know a lot about them, but they're core to a lot of what AI is going forward. And I want to talk about the human aspects of this and what do we understand about them. And so in some sense, it's kind of like this famous graphic. There's a bunch of text out there. Nobody quite understands what it does. The thing that just kills me about language models is that people have been building them now for a while, right? They've been around for 12 years or something like that. And fundamentally, when people say, oh, this is how it works, they're lying to you, right? There's a bunch of stuff that happens, and people don't really understand it. And I think this is going to be the case forever. We have things we can do, and so we can go to a language model and say something like this and get a nice, plausible answer back. That's lovely. I love it. You can ask questions about soup or something that's savory and get alternatives. You know how this works. So if you ask this question, like, what is the most interesting course offered at Stanford? A language model is a language model. It's not a model of interest. So what gets listed here is based on the conditional probabilities of words that are out there on people's blog posts and Rate My Professor sites and so on. And so I'm disappointed that my class is not there. But what's super interesting about this, if you ask this, this is a little bit later. This is Gemini on the left and OpenAI on the right. What's fascinating about this one, this was a couple, when was this? This was 2 years ago. When Peter asked this question, most interesting answer, it gives you a totally different answer, which is interesting. It also says, I don't have real-time information access, right, as of 2021. So that's the notion of a knowledge cutoff. So the way a language model works is you build the model, you train it. That's what the T means in GPT, right? You train it up with a whole pile of data, and that's what takes all the power. And it usually takes a lot of dollars. A typical training problem costs, on the order of millions of dollars, kind of thing. But it has a knowledge cutoff because you as of that day. So that was as of 2003. And OpenAI said at this point that they're going to keep their model updated. They're going to rebuild it, so it's always within 3 months. So they'll do it 4 times a year, right? That was 2 years ago, which, as you know, is infinitely far ago. Okay, so now I ran this over the weekend. What's the most interesting course offered at Stanford? My class is still not on the list. So I'm still annoyed. But what I found so interesting is that the top 2 classes that are most interesting, according to ChatGPT, is using AI to make rules and law, CS50, and CS330. So I thought, wait a second. CS50? I've been at Stanford for a while, and I thought, I've never heard of that course. So I looked it up, and the answer is, it hasn't been offered for years, right? So there's a real-time problem. And what's even worse is that a lot of the language models, the OpenAI and Gemini and all these things, are saying we now have real-time access to the web. Remember that. We now have real-time access to the web. But the other thing about this is this other course, CS330, is described in ChatGPT as a course that's taught by Sam Altman and Andrew Ng, I think. Very famous people. And I thought, oh, really? I don't think they teach that course. So I went and checked. They spoke in that course 4 years ago. That's not the same as teaching the course. So it's not real knowledge, it's probability. So now when I ask you, my class is still not here. So I need you to go out and write blog posts that say, I'm trying to bump up my probabilities here. I'm going to skip this one. I will give this to you as a break assignment. Just think about when you come back from break in a few minutes. What are the top 3 issues with language models? Okay. And let's start by, I'm going to give you, well, tell you what, forget that. I'm going to tell you what I think the top problems are, right? Hallucination. Everybody's heard about hallucination in language models, right? It just makes stuff up. And then there's gullibility. And so we'll talk about, I forgot to talk about jailbreaks. Darn it. Everybody know what a jailbreak is? Okay. The usual suspects know, okay. Large language models can be gullible. They will believe anything, right? So it's like if I say to you, you know, the dictionary has removed a word from the dictionary this past year. You say, what? I say, it was the word gullible. And you would believe that, right? Or gullibility, you can talk a large language model into almost anything. And that's one of the problems. So other issues are, misinformation, perpetuating things that it has found out on the web because it doesn't know the truth from false, disinformation and so on. So all these sort of issues. And I wanted to bring out the last 2 points here. Job and task disruption. The nature of work, your work, is going to change, right? So when I asked you earlier about vibe coding, vibe programming, if you're a coder and you haven't used a language model to help you code, get busy. Figure out how to do it. I'll give that to you as an assignment. So there's a problem with it, and Peter will talk about that in detail tomorrow. But it's one of those things that's shifting the way we're thinking about coding going forward. It's shifting the way paralegals work. It's shifting the way everybody does almost everything. It's certainly affecting graphic designers a lot, right? So I guess the real question here, I want to, in the transition here, is this different than other technologies in the past? So recently in the US, there was the Screen Actors Guild, SAG, and a bunch of the acting population had a big strike for quite a while, protesting, among other things, the introduction of large language models to write scripts. And the thing is, they can actually do a decent job of it, as sort of the humans are protesting this. Now, I want you to think about the Luddite riots and the swing riots from the 19th century. Both of those were cases of the Luddite riots were people who were objecting to the introduction of new cloth-making technology, steam-powered looms that were able to make a cloth much faster than the manual, back and forth motions that people did. And in the swing riots, it was the introduction of a new technology, which was horse-powered threshing machines, machines that would separate the kernels of wheat from the chaff. So in both cases, people rioted and went wild. In both cases, they were correct. Their jobs were being removed, right? So the number of people who were making cloth, for example, before the riot versus after, the machines really, is like a 10-to-1 replacement. So it was much more efficient. And of course now, how many people do you know that make cloth? Very few. I mean, they're all done by machines somewhere else. So the efficiency costs are really interesting and important. These riots, both of them, which were major movements, ended up making interesting social changes. Worker protections came into being, even though after the swing riots, something like 250 people were hung, but it affected social change. So as difficult as that is to believe, it's one of those things where, protests actually do affect social change. With that as a thought, let's take a 5-minute break, come back at 9, and we'll finish up language models. Oops.
Oh, that was a while ago.
I exactly have that. But I this sense for like 1 month almost. And like all of this is like defined like it's yeah. And I haven't read anything. I mean for
comment was about one image you asked us to be fully generated. If I remember correctly, and slide later. Yeah, and in case if I do like comments or stuff is possible to increase the grade or so it's great.
But in fact, you're not the only person to ask this question. So what I should make a general. The questions in there. What would you do? This one. How can you?
Yes, what was that?
So generally,
How many weeks ago? This was like I remember it like it was yesterday. No sense of time passing.
Is there a way to increase the grade?
No.
Okay, that's first answer.
That's fine.
So it seems like the first thing I missed the aspect for the second approach. And so I don't think that's a break. Because I don't think it's should I do something?
No, you shouldn't. Let me check and see what why Libra was not giving you a grade. You might just maybe you forgot.
Or because I thought when he asked me before I was second.
No. He's just saying that is missing. So I wanted to check.
On this scrolling, okay.
In our return.
Should I send you an email?
Yes. Double check my grade.
Thank you so much.
I really am interested in UX design. But what would, from your aspect, what would be a good background for me to go to this path as if I want to do as a class? Because then,
Well, it's an interesting question because it's changing a lot right
yes.
now. So this class is great for you. This is a good start.
Yeah, after this class.
You know, do you follow Jacob Nelson? Oh, I know who you should follow. Javier Vargas.
Javier Vargas.
Yeah, when you send me the note, just say, remind me who I should follow about UX, design or research. You want to do design?
I think research is much more fun than design.
I think so, but whatever, right?
Right.
Yeah. Anyway, I'll recommend. Ask me to make that recommendation for people for you to check with. The reason I recommend Javier is that he's in Basel. He's kind of local. He used to work here in Zurich. Now he's in Basel, and he knows the Swiss landscape really quite well. So yeah, he's a better connection than I am actually. And he also organizes these meetups every so often, like once a quarter or something, for exactly people like you.
Okay.
All right? So drop me the email and ask about the grade and the recommendation.
Yes.
Okay?
Yes. But the thing for me is I'm not live here. I'm an exchange student. My
Okay.
background is Taiwan.
Oh, okay. Well, okay. then I will make a slightly different recommendation. Yeah. No, having said that, I don't know anything about the UX world in Taiwan.
But no, I'm thinking I do want to stay here, or I can go to the US. I still have my green card.
Oh, wow. Cool. That's great.
So we will see.
Yeah. Yeah. I'll make you a good recommendation. Okay.
Thank you so much.
Sure. So with every new technology has adoption issues, right? And in particular, ones that cause job displacement or task redefinitions. It can cause huge issues. But language models are interesting because if you're an AI person, you kind of know how they work and you understand the limitations on them. But the perception is very different. So remember we talked before about how people have this inevitable social response to computers? Remember that? Well, there's this thing called the Chauncey Gardner effect for this movie from more than a few years ago. But he's this guy in the movie who's a simple gardener. He doesn't know much of anything beyond the gardening. And he ends up, by accident, becoming an advisor to the President of the United States. And people, interpret what he's saying as these clever metaphors. He would say things like, "We must prune the garden and water the garden." And people go, "Oh, that's advice about international financial policy." And so if it sounds smart, it must be smart. And so people ascribe all kinds of intentionality and intelligence to AI systems that's not really there. So NLP, right, there's a whole set of classes on just this topic alone, but we're going to talk about just a couple concepts that are important for us. First off, natural language, as you know, is this complicated thing where we have words, we have syntax, we have relationships, I have all these different pieces. And there are multiple different languages, and they operate in very different ways. Okay? They evolve over time. By contrast, we also have formal languages. So think of programming languages or data representation languages and so on. So they have very precise grammar. You probably had a program fail because you forgot a semicolon, right? I have, right? So they're super precise, super picky. So, however, Andrej Karpathy wrote this a little while ago saying that the new programming language is English. And the funny thing about that is people have tried for years to make programming languages that were more and more English-like. But then all that happened was the precision got kind of muddled down. BASIC as a programming language was an attempt to make an improvement over the readability over previous languages. And COBOL, if anybody remembers that, was another attempt at doing that. But, vibe coding, again, tomorrow, suggests that there's going to be something really new and interesting. There are systems that handle these semi-formal languages. So semi-formal means that, for example, you can express something in classic sort of mathematical representation. And Wolfram Alpha, if you don't know about it, is a kind of a mathematics genius. So you can say things in text like, I don't have any. Oh yeah, here's one. You can say things like this. Give me the integral of x to the fifth with respect to x. This is not a language model. This is just a clever parser. This is classic NLP parsing. But it converts this semi-formal representation into a formal representation, which then gets handled by the backend. Right? So actually, if you don't know about this, I wish I'd had this when I was doing calculus. It would have changed my life. Now, we have this notion in natural language and knowledge representation about atomic symbols. So a symbol like triangle or a symbol like justice, a lot of these things can be formally defined. A triangle, the concept of triangle is very clear what it is. But justice, define justice. Even defining a chair is hard. So is it maybe that we should be giving up on symbols? So one way to think about symbols is just as points in a high dimensional space. This is where large language models are going, right? So we have these notions. So this is, just a down projected example of a bunch of words and sort of mutual similarities. And so large language models based on neural networks play on that notion of this high dimensional projection stuff. And so the technology for this is that we have these word vectors. So words are not just atoms, but they're embedded in this high dimensional space. I'm not going to teach you how to do that. I'm just giving you the overall gestalt here. And so these word vectors are these points in space, and transformer model is something that, as a mechanism we use to pay attention to different parts of the text that's going by, and we have mechanisms to adapt what's going on in that processing. So prompting is obviously, you do that when you use ChatGPT. You prompt to get something to do something. You fine-tune a language model by adding additional information on top of it, and then we all know about reinforcement learning with human feedback. So word vectors, right? The key idea behind a word vector is that each word is represented by a vector in this high-dimensional space. And so similarity is 2 points that are close together in this dimensional space. So co-occurrence within a window, a sample of that, right, can tell us what words are similar to it. So John Firth is famous for saying, you know a word by the company it keeps. And so you can go this demo and start to compute this similarity between terms like animal and aardvark. It's 0.9, that's pretty high. Or animal and black, it's pretty low, 0.07. So you can start to see by using these nearness measures what the rough semantics of a word are. Okay? Now I point out that the terms on the left are given by humans. The columns on the right are analysis. So what the model doesn't know that that's the concept here of spooky, but someone went in and labeled it. So you can do these things, and you can get similarity measures. You start to see where this is leading. Similar words start to be able to have similar points in space. And you can measure the cosine difference, the difference between these two places. Now, if you take, for example, pairs of words like Tokyo and Japan, and then if I just gave it Beijing here, you could project that China would be the corresponding thing to that. So all of a sudden, you can think of a vector here. If I don't know this word, but I know this word, and I know that this vector is a relationship between words, I can drop the vector in and predict what the corresponding word would be. What in this case is the vector is country of, or capital of. So you've got your standard neural networks that process these things. We have deep neural networks that have multiple layers. We have all these different mechanisms for capturing semantics by going, for example, from one-to-one to one-to-many and all this sort of stuff. Recurrent models. This is what you learn in AI 101 these days. I wanted to show you this because what's happening when you look at a model like that is if you poke at one of these nodes, what does that node mean in some sense? One of the things that you can find is that, do I have another? Yes, I do. These, if you poke and look at those cells, you can find cells which activate or deactivate red versus blue, depending on the position of that word in a sentence. So that cell, out of the millions of cells, is encoding sentence length or sentence position. So if you start to poke around in that neural network, you find lots of cells that do things like this. A cell that turns on inside of quotes, or a cell that turns on when it's mentioning a relationship between people. All of a sudden, those little cells start to have semantics. So the problem is, a lot of these things are slow on the current hardware. People are inventing new things all the time, so this is all getting better and better. Then there's, the vanishing gradient problem where, you have a problem of, how do you use information at the beginning of the sentence to the end of the sentence and make sense out of all that? So there are lots of approaches like the long short-term memory, LSTM method. And the best current solution are these transformer networks. I know I'm compressing a lot of stuff here. Okay, what I want to get to is this notion that transformers rule. And a transformer takes a whole sequence of words, in our case actually tokens, all at once in parallel. So it's like that deeply connected neural network model. And it produces a whole set of outputs simultaneously. So this is not what people do, right? What people do is they process sequentially, maybe with a little window. But one of the major advantages of language models like this, built on transformers, is that they can understand the whole thing simultaneously. So you probably heard about the context windows. A couple of years ago, the context windows, I remember when they were 100. And I thought, yeah, 100 words, right? And now, of course, they're like on the order of millions. So the context window is this, basically, what's going into the system and what gets paid attention to. That's why we can now have systems that actually, where you can write something fairly long, and the beginning, it coheres with the end. That was not true when you had a small context window. It's kind of, think of it like it's the part of the text that the system pays attention to. So these causal models, these transformer networks, do a pretty good job, for example, of matching query statements like, please tell me the capital of Russia, to that corresponding term in its vector model. So we've got these. I'm going to skip over this because I want to get to this part. We got this thing. You train it using this mechanism, these neural mechanisms, and you train it and do what's called pre-training to build a completed system. And that's where all the money goes, is in training a model. So ChatGPT's got 20 of them or something. Gemini's got, Google's got, 21 of them or so. Meta's got a couple, et cetera, et cetera. And that's what they do, is they build all these models and they train them for a specific task, or a specific kind of thing. So typically what happens is that people, when they're using a language model, pick one. Go ahead, ChatGPT 4.0 dot whatever, right? And you can use that one to answer your questions, but it has a whole bunch of assumptions built into it based on the training, which you don't know what it is, because I'm not going to tell you. So kind of a problem. So once you train this thing, the idea is that you can use as few shot learning as possible as a way of getting it to give you an answer. So a shot is an example of, right? So ideally you want 0 shot, so it will just answer the question out of the box. But you can do things like this. Give it a couple of examples of training from German to English, English to Dutch, and so on. And you can actually then get it to do the right thing. So I want to focus a little bit on just prompt engineering. So you've all been little prompt engineers, right? So for the last assignment, you'd used prompt engineering to get your invitation could come out. But if you want to be slightly better, let me tell you a few things. You can give it an effective, so this is a prompt you might give it, but one thing you might do is make it longer, and let's dissect this prompt down a little bit. I'll show you the pieces of it. Now, I will say it as a way of a caution. I will tell you the advice I'm giving you now. This might change in a year, okay? Be that as it may, this is what I would recommend. You make your prompt longer, and it has a couple pieces to it. First, give more context about the task goals. So for example, describe this process you would follow. I'm giving it a context. Give it specific text steps to do. So include text to explore sale trends over time, identify top selling products, and so on. So notice the difference between this and this. There's a whole bunch of details left out. And if you're lucky, it will agree with you, but you're not going to be lucky. Okay? So give more detail about what specific behaviors you want, and be as clear as possible. So for example, instead of tell me about dogs, instead use something like provide a detailed description of the characteristics, behavior, and care required for domestic dogs. See the difference? Be specific. Provide some context so you can the system can understand what's going on, and be as precise as possible. So, for example, list the 10 most populous countries in the world. You can even give it a role to play. So, as a piece of advice, say, as a historian, blah, 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 blah. So, in the example I gave you earlier, I said, write this report as though it were for a graduate student. Okay? I'm giving it a role to play. So, be clear, be precise, give enough context, and use role-playing language. One thing that's become popular in the past year or two is this step-by-step thing, sometimes called chain of thought reasoning. So I can say, show your sources, show your steps, act as if you were a whatever. So these are all prompts you can use in order to get it to do this step-by-step thinking, following the guidelines of blah, blah, blah. So these are all different pieces of prompts you can use in order to make your effect better. So these are some key phrases. As you know from your assignment, iterating is really important. You have to continuously do this a few times until you get it right. Now, fine-tuning is, so typically what people do is they grab the pre-trained model, GPT 4.0, whatever, and then they can fine-tune it by giving it additional information. So fine-tuning is dumping in additional content in order to put it in, think of it as putting it in the right mindset. So let me tell you a bunch of Spanish things. So I will write a whole bunch of Spanish things, and then I can ask a question about it in Spanish. So what you're doing is basically torquing or twisting the model to be more like what you want it to be. I want it to be a Swiss expert. So I'm going to tell it a whole bunch of, give it a whole bunch of fine-tuning data about, say, Swiss regulations and lifestyle and so on. Or you might fine-tune for a particular subject like chemistry or politics. So fine-tuning just means dumping a whole bunch of additional information into the system on the topic that you're interested in. And it kind of works pretty well, actually. In this version, you can ask a question like this, which will summarize it. And if you fine-tune it, you can actually, this whole paper is about this topic. But on the other hand, there are some things it can't do. So you can fine-tune for things that are naturally linguistic. But there's interesting questions here. How would you fine-tune it for music theory, for chords? It doesn't quite mesh with the model. So don't try to get it to do things that are outside the model space. On the other hand, with the rise of multimodal models, you can do things like this. So remember the very first example I said, do an invitation in the style of this image? Same idea. So here, given it an image, in this case a little schematic diagram, which now ChatGPT can, or this is the case Bing, which is ultimately ChatGPT, can do things with that image. So that's fine-tuning. So now what would I expect? If I ask questions about circuitry, it's going to be fine-tuned for that, right? So here's kind of the playbook. You're looking for, if you're going to do something with this, they create a new agent. You select a model, you define the task, prepare the data, do a fine-tuning process, right? You then set that all up, fine-tune your model with additional data, make sure it's working, doing the right thing, you iterate and test until you get the whole thing working. So this is the modern way to build models for your task. Right? So reinforcement learning with human feedback, I mentioned earlier, is basically the way the big guys train their systems to be competent in a particular domain. So they run lots of examples, and they then say, hey, human, is this right? So on the other hand, reinforcement learning feedback by humans is expensive, slow, and painful. So we're trying to figure out ways to do this better. For example, by having one agent give reinforcement learning to another agent. That's tricky. That's still in the realm of research, so we're working on that. But let me see, do I have an example here? Yeah, here we go. So in step one, you collect this demonstration data, and you're trying to, for example, train a policy, like a guardrail for a language model that would say, don't talk about violent imagery. When you see things that are violent, just don't do that. And so a prompt comes out from the prompt data set. That's human curated data set with examples of people prompting for violent imagery. And then a human rater says, oh, that's good or bad, or you should do this instead. That then gets put back into the model to train it. Okay, so that's what step one is. That's a human in the loop reinforcement training. Another step here is to then do rating. So once you've got it rated, trained, you then create multiple versions of it and then rate the best option. That's another kind of fine-tuning. Okay, so you do rewards for that. And then you can start to optimize the policy. And in this case, the policy is prompts that are given by the system by the company to the system to modify its behavior. So one of those prompts would be, a policy prompt would be something like, don't talk about violent imagery, that kind of thing. Interestingly, it does not include eliminating toxic or misinformation in the training model. And the reason is, because it's a pain to get rid of it. It's, ultimately what you'd love to do is to be able to have at this step, at the very early step during the training process, remove the violent or whatever objectionable content. But that's really, really, really difficult because there's a few, exabytes of data. And so eliminating it one by one is just losing proposition, because then when you go to the next model, you have to re-edit it again, and that's just way too expensive. So when you do this kind of reinforcement learning, you can do things like gender agreement for, say, translation purposes. So Google Translate did this for all the languages, and that's a nice example in Turkish. So there's all these different steps here. You need to know about fine-tuning, because you may be called upon to fine-tune the model that your company is using. So suppose you are the UX engineer for a company that's doing customer support, and you're building an agent to help people, right? How do you fine-tune it? Well, you fine-tune it with content that's appropriate for your company. So if your company is, say, a metalworking company, you would probably want to fine-tune it with content about metals, right? Metalworking processes and so on. Then prompt engineering, right, is the step when you create the prompts that drive your system. So if you're, again, doing this customer support agent, you might want to create prompts that tell it the kinds of things, the kind of policies you want that thing to do, right? And then if you're involved in the back-end production, you might use reinforcement learning using human feedback. But this is really for the Googles and the Amazons and the Microsofts of the world. So you can imagine, I showed you this list before. You can do all kinds of things, and probably more things as multimodal capabilities come online, more things that we can do. But the ones I'm most interested in are these two right here, searching and answering questions. But there's a lot of stuff that these models can do. So let me give you an example. A real AI agent model that might be useful to you would be a job interview prep agent, right? The idea is that, as demonstrated in this, I'll show you a little video here in a second, you can actually talk to someone to practice your job interview skills. Wouldn't that be great? Especially if you could do that at midnight. Fabulous, right? So how do you do that? So let me show you, and then I'll talk about how it's done.
Can you please tell me a bit about yourself?
Hi, I'm Lamont. I'm from Washington, D.C. I'm currently certified in IT support. Some really great practices for securing a home network is always keep my career goal is last year I graduated with the Google IT support certificate. Before that, I was self-employed for about 13 years, and I had never really done any interviews. I'm really interested in it's a very anxious feeling.
During the pandemic, career mobility became an even bigger thing. And on the other hand, there are more than 1.3 million job openings in the US in fast-growing, high-paying fields like IT support, UX design, project management, and data analytics. So Google started the Career Certificate program to help people make that career transition. But we found that the one thing they had a hard time with was interviewing. We were working on other conversational AI research at the time. So we tried to think, could we use machine learning and large language models to build a tool to help you practice for a job interview? We started working with the certificate learners right from the beginning to understand how are they currently practicing for interviews and how could we help.
Experience, motivation, skills.
We needed to get people speaking out loud into the computer.
I would be a great fit for this role.
And then we transcribe what you're saying and analyze your answers, showing where you repeat a word or where it's useful to use key terms in your answer. With interview warm-up, the goal is to create the safe space where you could practice as many times as you like.
Let's practice an interview for project management.
I would prefer the agile method.
Because I'm very passionate about troubleshooting.
As well as data interpretation and storytelling.
Okay, great. Thank you for sharing. Now you can review your answers.
I don't know how it's made. It's like magic. You're learning to answer these questions in a much...
Well, who knows what happened. But I'll tell you what's going on there is it's an agent you can talk to. And so we'll give you a prompt like, tell me more about yourself, or tell me about your experience in developing software, or tell me about a difficult management experience you had. And then you speak as though you're speaking to a human interviewer. And it transcribes what you said and gives you feedback on it, right? So for example, I know that when I transcribe my lectures, I know I say the word right once a minute. That's a piece of feedback it gave me. Maybe you don't want to say that word quite as much as you do, right? For example. So this is a way of basically embodying what a human would give as feedback to somebody searching for a job. So it actually works quite well. Okay, is that it, really? I guess that's it.